So here we are going to discuss about what are the different types of failures in the riveted joint. Okay, so this is very important to understand to find the strength of the riveted joints in a machine design. Okay, so here there are 4 to 5 types of failures in the riveted joint. In that, first one is tearing of the plate, tearing of the plate at an edge, at a edge. Okay, so it means, here I will explain. So tearing of the plate at an edge. For example, if you are having a lap joint. Okay, so lap joint means there are two plates which are overlap each other, and a rivet is done here. Okay, the riveting is done to the lap joint. So tearing of the plate, it means when you apply some tensile forces to these main plates. Okay, these are the main plates. So in the plate, so there may be chance of failure in the plate due to this maintaining of the margin. For example, if this is the center of the rivet and this is the edge, okay, end of the plate, or you can say edge. So if there is a shorter distance between these two, the length between these two is having short distance. If you not maintain a proper proportion, that we call as margin. Okay, so margin should be maintained. Okay, so that we can avoid this tearing of the plate. Tearing means generally for example, if you look at the top view, if there is an rivet here from the top view and this is an edge, okay, from here to here. So if a margin is not provided from a center of rivet to the edge, then the rivet or the plate, okay, in the plate it may get tear off like this. So we have to maintain this proportion where margin, it is written as m, small m, that should be is equal to 1.5 into small d. So this d indicates the diameter of the rivet. Okay, so this is the solution for the tearing of the plate at an edge. Second one, same, there will be tearing of the plate across a row of rivets. A row of rivets. It means the rivets are arranged in a parallel. Okay, for example, if you take the same rivet in the top view, so in the top view we can see the two rivets arranged like this. There may be more number of rivets are arranged in a parallel. Okay, so this is the center of the rivets. So the center of rivet from one rivet to the another rivet, we call it is as pitch, right? And the distance between these two circles will be taken as pitch minus d. So this distance, okay, so this semicircle and this semicircle, total it will be taken as d. So where total pitch minus d will be the area of this. So during these two, if you not maintain a proper distance from one rivet to the another rivet, so in the plate there may be tearing occurs between these two plates. Okay, in the plates. So to avoid that, we have to use this equation to give a proper distance. Okay, so what is the area in that place? So area, let us say a suffix t, t is for tearing. So area, it is p minus d. So again the thickness of the plate will be completing by making the multiplication with that distance into T. So that become the area of the plate. Okay, now what is the tearing of the plate per pitch length? That is P suffix T will say. Tearing of the plate per pitch length. Okay, so that is equal to area of the plate into the strength, that is tensile strength. Okay, again we can write this equation as area is equal to P minus D into T into sigma T. So this is the tearing resistance of the plate. Always remember that P tearing resistance that should be greater than the which load you apply. The load is P. It should be always greater. Okay, P suffix T should be greater. Then only the design will be safe. Now the third one. Okay, this is about the tearing. Now third one, it is related to shearing. Okay, so shearing of the rivet. Generally shearing will be done at the rivets. Okay, so shearing means you have to understand first. So here in this case, if you apply the two loads, okay, so for this rivet, the shearing is what? If you apply two loads, the rivet may get shear off like this. Okay, so in the plate, it may get the shear off. So in this case, the number of shears are 1. Okay, so in case of there is an butt joint. Okay, so in butt joint also there is a single cover plate, double cover plate, single strap or double strap we used to say. So in case of double strap, okay, generally double strap will be taken as 2 cover plates and there will be middle having main plates and another cover plates. So here the riveting is done. So when you apply the loads, the shearing will be done at the one section here. Okay, I will make some coloring here so that you can understand like this. Okay, so shearing will be done here one time and in the same below 2 times. So only in case of double cover plate, number of shears are 2. Other than that, generally you will get 1. Okay, so for that area of the shearing, let us say A suffix S. So for rivet, only diameter is taken. So area will be pi by 4 for a circular section, D square. Okay, like this. And shearing of the rivets per pitch length, that is P suffix S. Area of the plate pi by 4 into D square into tau. Tau will be taken. Okay, for the shearing. For the tensile, sigma T. For the shearing, tau will be related. Again here, as I told you, number of rivets and number of shear-offs both are different. Okay, number of rivets are different. For example, here the number of rivets is 1. If I used one more rivets arranged parallel to this, so number of rivets are 2 here. Number of rivets are 3 here. But shear-off will be only 1 for lap joint. Okay, so number of rivets in this case 3. But number of shear-offs, I will say shear-off is 1. So I will make multiplication n to the equation where n indicates the number of rivets are arranged in a lap joint. So 1, so if there is a 1, let us say 1. If there is a 2, 2. If there are 3 rows, say number of rivets are 3. Okay, so that is called. But in case of, if there is a double riveted, for example, if I use another rivet here for the butt joint. So in this case, there are 2 rivets. Number of rivets are 2. Number of shears are, number of shear of also 2. It means it should be for, in case of double, 2 number of n into 2 into pi by 4 into d square into tau. So this equation, it will be used for double shear off, right? So number of rivets, it may be 1, it may be 2, it may be 3, but shear offs are 2 for double. Okay, it means if it is an butt joint for double strap, Then third one we'll understand now. The fourth one is crushing. Okay, so crushing of the plate or crushing of the plate generally. Okay, so crushing means we have to understand now. For example, we have one plate having some thickness and made and hole. So the riveting is done for both the plates. Okay, two plates are there. The riveting is done now. Having rivet, inserted riveting, and the rivet is done. So now if you apply some forces here, so due to that force, the rivets it make the regular circle or regular hole into a different shape. Sometimes it may be oval shape, sometimes it may be irregular shape. So that makes a loose in the joints. Okay, so it may be chance of some leakages in the fluids. So different cases it may happen. So to avoid that, so we have to make more strength in the crushing. Okay, so for that, what will be the area for this? So area, it will be generally AC. C indicates the crushing area, where D is the diameter of the rivet or diameter of the hole, both are same. So diameter of the rivet into the thickness of the plate, it becomes the area. And how many rivets are using? Again here, same as I told you in the sharing. How many rivets are arranged? So it may be 1, it may be 2, it may be 3. So like that, again, the strength in the crushing per pitch length, that is P suffix T. That is D to area as A suffix C, that is equal to D into T, and the strength, crushing strength, that is sigma C. Again, I used where n, small n, that indicates the number of rivets. Okay, number of rivets, it may be 1, 2, 3. So that you have to use where D is the again diameter, T is the thickness. Again in this case, where in all the cases, it may be tearing, it may be shearing, it may be crushing. So all this in all PT, PS and PC, all these should be greater than the load applied. Okay, the load, whatever the load you are applying on the plate, so everything, all these strengths should be greater than the applied loads. Then only the design will be safe, and we can say that it is a good design, or it may be to avoid all these type of failures in the riveted joint. Hope you understood the concept. So thank you.